In this video, we are going to talk about how to draw a Lewis structure for atoms and molecules. The most helpful tools for that is the periodic table. And the most important information is finding location of atoms in the periodic table and figuring out the number of their valence electrons. To get the number of valence electrons, what you need to do is counting the columns starting from left in the periodic table. So column 1, column 2, we jump across transition metals, 3, 4, 5, 6, 7, and 8. These numbers are the number of valence electrons for all atoms in the corresponding column. For example, all atoms in column 1 have valence electron equals to 1. All atoms in column 2 have valence electron equals to 2. The only exception is helium that only has 2 valence electrons. Now, let's look at some of the examples. Hydrogen. We know that hydrogen is in group 1, so it should have 1 valence electron. To show the valence electron on a single atom, we use Lewis dot structure. Hydrogen has 1 valence electron, so I put 1 dot on hydrogen. Now, let's take a look at oxygen. Oxygen is in group 6, so it should have 6 valence electron. To show 6 valence electrons around oxygen, what I need to do is first spread electrons out and then start pairing them up. So 1, 2, 3, 4. I put 4 electrons in 4 sides around oxygen, and then I start pairing them with the remaining electrons, 5 and 6. In this way, we can show how many bonds can a single atom make in the molecules. So oxygen has 2 unpaired electrons. That means it can make 2 bonds in molecules. Now, let's look at bromine. Bromine is in group 7, so it should have 7 valence electrons. I start putting electrons in 4 different sides, and then I pair them with the remaining electrons. Overall, 7 electrons on the bromine. Bromine has 1 unpaired electron. That means it can make 1 bond in the molecules. Now let's use this information and draw a Lewis structure for carbon tetrachloride. There are 4 important steps that you need to follow when drawing the Lewis structure. Step 1 is counting valence electrons for the molecule. Carbon tetrachloride has 1 carbon, and we know that carbon is in group 4, so it should have 4 valence electrons, and it has 4 chlorines. Chlorine is in group 7, so it should have 7 valence electrons, and we have 4 of them, so overall 28 valence electrons. If you do the math and add these numbers together, you are going to figure out the number of valence electrons for carbon tetrachloride, which is 32 here. Step 2 is determining the central atom. Central atom is the one that all of the other atoms will be bonded to, and usually it's the least electronegative atom in the molecule. So here we used carbon tetrachloride, which is made of carbon and chlorine. If you remember the electronegativity trend in the periodic table, carbon is less electronegative than chlorine. So we have carbon as a central atom, and we have 4 chlorines around it. To add those chlorine to the central atom, I use a bond and I connect each chlorine with a single bond to the central atom. So each bond accounts for 2 electrons. I used 1, 2, 3, 4 bonds to connect those chlorines to the central atom. That means overall I used 8 electrons out of the 32 valence electrons that we calculated. So 32 valence electrons minus 8 electrons that I used for drawing bonds equals to 24 remaining electrons. The next step is distributing the remaining electrons to the outer atoms to complete their octet. So, the outer atoms here are 4 chlorines. I have 24 remaining electrons. So I start adding those remaining electrons to the chlorines to make them octet, and I start from the chlorine in the right. So 2, 4, 6. And I know each bond accounts for 2 electrons, so overall 8 electrons around this chlorine. That means the chlorine is octet. I use 6 electrons out of the remaining 24. So then I move on to the next chlorine. 2, 4, 6. So overall, I used 12 electrons till now, and all these 2 chlorines are octet. 14, 16, 18, 20, 22, 24. So I used all 24 remaining electrons, and I made all the atoms, all the chlorines, octet. Let's look at the central atom and check if it is octet or not. 2, 4, 6, 8 electrons around the central carbon atom. It's octet. Now, the fourth step is recounting the valence electrons and compare it to the number that we calculated in step 1. So let's do it together. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. The number matches the number that we calculated in step 1. So this Lewis structure is acceptable. This is how we draw Lewis structure. And in the next video, we will work on more complicated molecules and calculation of formal charges for each atoms in the molecule.